Welcome back, everyone. This is the 6th Python tutorial of this series. So hopefully everyone watching has already attended or watched the first 5 tutorials. So far to review, we set up our workspace, we parsed a text file, computed wind chill index and heat index, and then we refactored our code into data reading and data printing modules. So if you had any technical difficulties so far, hopefully we were able to meet up and get you back up to speed. Today we're going to make a third computational module, and we'll also introduce the built-in Python package math. Before we begin, I need to review our code of conduct. By joining this Zoom call and participating in the tutorial series, you've agreed to adopt these values and engage in respectful communication only. Any inappropriate remarks will have you removed from the call. And again, please ask for help in the chat. People will be able to help you, but some questions will have to be addressed at the end or in one-on-one sessions. Here are some useful resources for you. Stack Overflow, Project Pythia, and the website that was built in 2020 to house this content. And just, to review, wind chill index, heat index, and then today we're introducing math, which we need for the logarithm to compute dew point temperature. So we're going to learn some syntax and functionality that we did not write ourselves, but that's already in the environment with your initial Python installation. So math is a module of mathematical functions defined by the C standard. And these functions don't work for complex numbers, but this package will cover a lot of mathematical applications and will be a great first package for you to work with that you didn't write your own before we start introducing more and more. Okay, so let's transition over to a terminal. Okay, is everyone in a terminal? Once here, again, move into your working directory. For me, that's in documents and then Python tutorial 22. And activate your conda environment. Conda activate, Python tutorial 22. Okay, let's take a look at what we have here. So we have our PyCache, which you remember from last time, is there because of importing our functions, and it's in our git ignore. We also have data, heat index comp, printing, reading, and our wind chill comp. So let's take a look at our wind chill script again. Okay, we've imported our read data and our print comparison functions. We have our columns and types dictionaries. We read the data in one line. We have a function. We call our function, and then we print our data with one line function call. This is much cleaner than it was at the beginning of last week. But we can make this even simpler by pulling out our wind chill function into a computation module that'll also have our heat index function. So I'm going to go ahead and copy this data right here. And let's leave and start our new file. Touch computation.py. And then go into that script. Just gonna go ahead and paste that right here. Okay, so like before, we are now going to also add a doc string to this function. Okay, and what a doc string looks like, again, is triple quotes. And between those triple quotes, we're going to have a description of what our function does and other relevant information. A good string for this function would be compute the wind chill factor, given the temperature and wind speed. Or maybe we should change this from compute to estimate. We'll go ahead and switch that now. Okay, and then we are going to add a note here. This is going to be new, but same idea. We have a parameter, we have a description, but we're just going to add a note here that there are limitations to where this function is valid. So this computation is valid only for temperatures between -45 up and +45 up. And for wind speeds between 3 miles per hour and 60 miles per hour. Now go ahead and list your parameters. So again, our parameters, we have T and B, and they map to the temperature in units of degrees Fahrenheit, and it is a float. The wind speed in units of miles per hour, also a float. Okay, that looks great. Let's go and grab our heat index function as well. So I'm going to save and open up the heat index comp. Take all of these lines of code right here. And go back into computation. And paste them. Okay. So one change we'll make in addition to the doc string is I'm going to show you how to use Python scientific notation. So you can do this with the capital E symbol instead of doing a 10 and then raising it to the power that you'd like. So let's go and change these. Where's the cursor? So hard to find sometimes. Okay, these first 4 we will leave the same. But the variable E we're going to change to be 6.8 and then -6.8 and then do E to the -3rd power. Similarly here, we're going to change this so we don't have all the zeros in the front. -2nd. This one's going to be the -3rd. -4th and -6th. Like so. Okay, and let's go up and add our doc string. It's also best practice or you'll see this a lot, is to have two blank lines in between functions in the same module. It just kind of helps you read because you'll often have blank lines for clarity in the middle of each function. So having a bigger gap makes it a little easier for you to see where one starts and one begins. Okay, and in here, triple quotes. Okay. Compute the heat index given temperature and humidity. Our parameters are T and RH. Oh, yes, let me, and hum, yes. We have humidity here as our input, and then we change it to relative humidity down here. Okay. The relative humidity in units of percent, the float. The temperature in units of F, and this is a float. Yes, I am forgetting one negative sign down here. Thanks, good catch. The G variable is, or G constant rather, is e to the negative third. Okay, so now with both of our functions here in the computation module, oh, actually we can delete this comment line. Where am I? Yes, right here. We don't want this line in there anymore. Just like that. Let's go and edit our wind chill function first to call up this function, and then do the same to heat index. Okay, so we have a third import statement at the top. From computation, import, compute wind chill. Let me go back and double check if that's what, I think it's actually called estimate wind chill. We can actually still see that down here because we used the same code. And then we can delete this function entirely. Oh, I accidentally deleted the wrong line. It's okay. I'll just write it again, which will be a second chance for anyone else to grab it. From computation, import, estimate wind chill. Down in here, we'll delete these three lines where we define our function. And now I'm actually going to show you list comprehension. So our function call right now is 3 lines where we establish an empty list, establish a for loop to go through and append data to that list. We can actually do this in 1 line. And not only is it 1 line, which is nicer on the eyes, it actually runs a lot faster. It's more computationally efficient in Python to use list comprehension than for loops. So I'm going to show you how to do that now. Right here. I'll leave the 2 lines there for comparison, but we're going to say wind chill is equal to a list like before, but instead of leaving that list empty inside of it, we're going to say estimate wind chill give it our parameters. And then we're going to establish what those parameters are. And so we'll say for T and V in, let's put a space here. And then we do our zip. Like that. So hopefully you can see how the syntax is basically a restructuring of these previous lines, the lines we had previously used. So again, we establish wind chill as a list, and we're saying calculate or estimate our wind chill for the values in this other list of our other tuple of our zipped data, which is very similar to saying wind chill is a list, and for the data in our zipped tuple, calculate and append it. Okay, so perhaps maybe that's a little confusing, but maybe you can kind of see how the syntax is just rearranged a little bit. It's faster, it's quicker to read for both humans and machines. Okay, and then I'll delete these 3 lines. And this is a nice cleaned up file. I'll go ahead and actually add comment here that's like estimate wind chill. Voila, just like that. Let's run it, make sure it works, and then do the same to our heat index function. Okay, looks good. Okay, so similarly, again, we are going to say from computation, import compute heat index. These files all look the same, but then we go ahead and delete the actual function definition. And we're going to replace it and these next 3 lines with the 1-line list comprehension. What that's going to look like, again, is heat index is equal to compute heat index for T and H for T comma H in zip data, and then we are giving it temp out and hum out. Like that. So we have the function we're calling with its arguments that are passed into it. And then we have to define those arguments as we go through our 1-line for loop list comprehension thing, which we define as iterating through our zipped tuple. Go ahead and, oh, I'm not sure what just happened. Sorry. Let's not save the changes again. I'll do this a second time for everyone. Okay, from computation, import compute heat index. Delete these lines. compute heat index, pass in our variables for, and we iterate them in our zip. Like that. And then I delete these 3 lines. Okay, I'm going to run this, see that it works, and then let's take some questions and make sure everyone is caught up at this point. Okay, we have an error message. That's fun. Okay, oh, yep, I put a V there by accident. For temperature and humidity in temp out. Okay, there we go. That looks great. If there's any questions, please go ahead and put them in the chat now. I want to make sure that this isn't confusing or losing anybody before we move forward. One of the reasons why list comprehension is faster than using a for loop to append a list is because you don't need to load the append attribute of a list, which means that you have to call up the whole list into active memory, append it, put it away, call it back up again over and over and over again. So it's much easier to just establish the list with all of its contents in one go at once, and Python knows that it's working on the same object. Okay, let's do a git commit. And we'll still have time for people to speak up if they need help. Let's do a git status real quick. You can see that we have 1 untracked file, 2 modified files. We can do a git stage, was it a capital A? Yep, and that moved all of our changes so that they're ready to be committed. Do a git commit, and we are creating a computation module. Okay. This 1 line git log with a git log -- 1 line, you can again see everything we've done. You can kind of see the history and the growth of our project, which is pretty exciting now that we have we've actually built up to something. We've actually built a Python package at this point. So you can see that we have quite a few files in the directory. And maybe we want to reorganize these a little bit. Typically, all of your modules that are meant for import are put inside a different directory that also has an init.py in it. So init.py is a special file that needs to be in a directory for Python to know to treat that directory like a package. So what we're going to make is going to be an empty init.py and a wonderful MySci folder to have all of our modules that we're using for import. Okay. So let's create our directory with make directory MySci. You can see that it's there. And let's move our desired modules into here. So you can do that with a git move. This both moves things in the git space and your directory space. We're going to move the read data to my side. We're going to move the printing to my side. And we're going to move computation to my side. Okay, now if we do an ls, this is a lot cleaner, perhaps. And we're going to go into my side to create our init.py file. And we're just going to do this with a touch file. Here, since we're going to leave our init file empty, you can see that while using touch is a very convenient way to make a file instead of opening and saving it something empty. This is very commonly empty, but sometimes certain packages have specifications on how to initialize the package, and this is where that information would go. So it's just required of all packages, even if your package doesn't have any special use cases going on. Okay, so now we need to edit our computation scripts to access our files from where they've been moved to. So let's go into Windchill comp. Oh, I must have spelled something wrong. Oh, I need to cd up a directory level so that we can access Windchill instead of creating a new mysci/Windchill. Okay, so now instead of just from reading, it's going to be from mysci dot read data, mysci dot printing, and mysci dot computation. So this dot is how you access a specific module within a package. Perhaps your first instinct would have been to put a backslash or something. So it's similar to how when we call up a function and then call up like a piece of it, like something dot plot. It's very similar syntax here. So from mysci, pull out read data, and then pull out and import read data, like so. Okay, we need to do the same thing to our heat index function. Okay, from mysci dot read data dot printing and dot computation. Okay, again, one git commit. Oh, what did I put? Oh, this one's a lowercase a. Untracked files. Please enter a commit message. Okay. I meant to do a git at .a is what's happening. And then do git commit your message, creating a mysci package. Okay. And just like that, you have made a package that has 3 different modules in it and is already being imported into 2 different scripts. So just a reminder for if you have some issues with the git commands in the terminal, like I just accidentally did. Some useful commands could be a git --help. And this will show you all the common commands that are available to you. You could also do git commit dash dash help if you needed help on a specific Git command. Okay, and you can get out of here with a colon and then Q for quit. Okay. So now let's create a new function as promised to compute dew point temperature. So what that's going to look like is we're going to move into, let me clear this to make sure everyone can see it. Nano MySci computation. Okay, and then go all the way to the bottom where we will create our new function. Okay, again, 2 blank spaces between functions, and we're going to call this compute dew point. And this requires temperature and humidity. And as I said before, we need to import math in order to do this. So we're actually going to go back to the top and add an import statement to this function, to this file as well. Import math, just like that at the top. And what you'll notice is that we've imported math to use this module, but then when we call up this module to use dew point that uses math, we don't have to import math again. It's already there. Okay, let's start with the doc string this time. Okay. Triple quotes, again, indent 4 spaces. What this function is going to do is compute the dew point temperature given the temperature and humidity. And here are the parameters we're going to pass into it. Temperature and humidity. This is the relative humidity in units of percent. And this is the temperature in units of Fahrenheit. Okay, and then end our doc string. Okay, but perhaps you noticed that the function that was in our slide from the very beginning of this session uses Celsius. So what we actually have to do is the first step is convert the parameters, the arguments that we passed into our function into the desired unit. So we're going to call it temp C for temperature in Celsius. And the way to do that is subtract 32 and then multiply by 5/9, like so. I'll add a 1-line comment here for temperature from degrees Fahrenheit, degrees Celsius. Similarly, our relative humidity, that's in units of percent. We actually want it as the decimal. We need it as a point system. So we're going to do relative humidity is H divided by 100. Okay, and then this time we have 2 constants. B, which is equal to 18.678. And C, which is equal to 257.14. And this one I know has units of degrees Celsius. Yep. So now we're going to introduce a gamma variable. And this is where we will use the math module. So we're going to call it math.log. Similarly to how we did printing.print data or print comparison, we access the math package that we've imported, we get into the logarithms, and we're going to call that on our relative humidity. And then the next phrase is the B value times our temp C, our temperature in Celsius, and this is all divided by C plus the temperature in Celsius. And then we're going to use this to actually calculate our dew point temperature, which is C times our gamma, and then divided by B minus gamma, like so. Now, we didn't strictly need to create a gamma, but you can see it's definitely way cleaner. It's way easier to pull that out there. So now our dew point temperature here is still in Celsius, and we're going to want to output it again in Fahrenheit. Dew point temperature in Fahrenheit, we just reverse what we did in the beginning. So 9/5 times the dew point temperature plus 32. Like so. And then I'll add a little comment here, convert temperature from degrees Celsius to degrees Fahrenheit. And return our value. So again, this function converts our initial temperature to degrees Celsius, specifies the constants that we need to use, calculates the dew point temperature, and converts that back into Fahrenheit. Okay, if anyone needs to see this for a little bit longer, please speak up in the chat, or I'll move on in about 3 breaths. Okay. Let's leave, save our changes. Now we need to create a file that computes dew point temperature by calling up this function. So we can make a copy of one of our other scripts and then edit it to see fit. Making a copy will make it easier for us to remember what all the steps were, and the syntax should be the same because most of the functions that we've used are now the same. So I'm going to copy wind chill. So I'm going to do that with CP for copy, wind chill comp.py, and then the desired file name for our copy. So dew point temp comp.py. Okay, and go into that new file. Okay, so lots of things that will need to be changed. The first one here, from mysci.computation, we are going to import compute dew point. That's a lowercase d. Python is case sensitive, so capital D dew point and lowercase d dew point are not going to be considered the same. Okay. Let's go into our columns. We have temperature, which we still want, but we want humidity instead of wind speed. Humout, which maps to the 5th index. And this script also has dew point, or this data file also already provides us with dew point, so we can go ahead and compare it just like the others. So dew point, and I can tell you that that one has the index of 6. Go ahead and change these same things to floats. We don't want them still being strings. Okay, now reading the data looks the same, but here we will actually compute dew point temperature. So we're going to go ahead and change some pieces of the script. So this here is going to be dew point, date of dew point, and oh, actually no, hum out. Sorry, I got ahead of myself. So now our zip data looks correct. Let's change these to H's for humidity. The name of our function is different. Compute underscore dew point, and the name of our variable is different. Dew point temp. Okay, and now the last line to change is in the comparison printing of our data. Okay, so the name of our variable that we want to print out is going to be dew point. We still want data, date and time, but then we want dew point from the file and from our calculation. Like so. Let's leave this and then go ahead and run it to make sure that everything works, have a chance to catch any syntax errors again before we move forward. So it's best to test your code between little changes. That way it's a little easier to catch errors before they snowball. So Python and run our script. Okay, that looks pretty good. Our differences are pretty small. Let's scroll all the way up again. Make sure that this still looks good. I think it does. Okay, that's great. Let's do a git commit. Git add dew point comp.py. Oh, it's git add dew point temp comp.py. And then git commit. Computed dew point temperature. Okay, so now let's explore the math module a little bit, see what other functions are in there that could be helpful for you. So do a touch math test.py. Go into that script. And we're just gonna play around, experiment with a few things. So the first thing we'll do here is actually import math. Instead of just importing math, you can actually do import math as M. The value in doing this is that as we go through and call up math a lot, we save those 3 characters every single time. We're just doing math m.log instead of math.log. Most packages have a common shorthand like this. It's definitely not necessary, but you'll see it commonly used when you're reading other Python code. So when you just import it as M, you're just changing the name basically in your workspace to something that's more convenient to you. So math has some built-in constants, like pi or Euler's number. So we'll look at that. With E is m dot E. We also have pi is m dot pi. Let's look at the logs and kind of expand our knowledge of how the logarithms are working. Okay. So let's say y natural is m dot log of E. Okay, so this is just like what we called in our dew point function, except now we're giving it a known value that we can predict what our output is to make sure that everything's working the way we expect it to. But you can also change the base of your logarithm function. So if you wanted to do something in base 10, you would do m dot log the value you're passing it, and then add a second argument that is your new base value. So again, like with keyword arguments, the base value does not have to always be entered. If it's not emptied, it's assumed that you're in base E. You might notice that we didn't say base equals 10. And that's because this keyword is the second argument. So if you wanted to call up various keywords in different orders, you would have to specify what they are. But if you just do them in their order, Python knows how to assign them. Okay, so this could be very helpful if, say, you want to do log 2 or something like that. For log 10, there actually is already a log 10 function that is just log 10 of log 10 of E. Oops, sorry, like so. Let's print this, make sure that everything is as we'd expect it to be. So we'll just do print our natural log, our base 10, where we changed the base, and we'll also print where we used the log that was already in base 10. Okay, let's leave this, execute it, come back, explore some more stuff. Okay. Call up your function with Python math test. So this is our value of E. The natural log of E is 1. And then you'll notice that there's some bitwise changes between these two values. They're still both good out to the very end. Basically, this ends in 0.76, and this one rounds that up to 8. I think what's happening under the hood might be slightly different between the two functions. So what Python first does for the one where we change the base is it calculates the natural log of the input value and then divides it by the natural log of your base. But for the log 10, it just knows how to do the logarithm of 10 off right away, which is more accurate and I think faster actually, but it has probably a different target of how many bits to show it to. Similarly, there's a log 2 instead of doing log, your value, and then your base 2. But that doesn't exist for every single number. Let's explore some trigonometry examples next. Okay. We can just comment out this line, but leave it there so you still have it for the future. Okay, let's say we have a degree of 180. And then radians is going to be our degrees times m dot pi, or you can just do pi because I defined it earlier just to play around, divided by 180. So there also is a radians function in math by itself. So you could do radians from func. And that is, you call it up with m dot radians, and then you just pass in the degrees. So we can see the differences between these values with a print, our degrees, our value of pi, and then the radians that we calculated by hand and the radians that we used the math function for. Okay. Let's call up this function. Okay, the value of pi, the value of pi and the value of pi. So here, all these values are the same, which is good. That's how you convert from degrees to radians. There also is, I think, math.degrees to convert from radians to degrees. But let's look at math.cosine next. Oh, sorry, nano math test.py. Okay, again, we could comment out this line so we don't print everything every time. This time, cosine is going to be math.cosine, and you can pass in your degrees. And let's also do it passing in the radians. Okay. So, let's print these two. Oh, let's actually give them different names here. So cosine from radians and cosine from degrees. And we'll print them both up. Like that. And let's exit and run the code. Oh, I have syntax error yet again. We called it rads for radians. Okay, so what you would expect your cosine of pi or 180 to be is -1. So this just shows you that the cosine function is taking in radians. It's assuming that the value you pass it is in radians, not in degrees. And so you know how to convert to from degrees to radians to get the desired input. Okay. There are also, there's sine, tangent, all the same syntax for all of those trigonometry functions. So definitely look at the math documentation to learn more. I'll go and paste that in the chat here. And this has a list of all of the various functions that are input in math. It has their doc strings there and sometimes examples of how to call them. Okay. So that's a great way to get more resources, to explore more. Yeah. So we're at the top of the hour. So I think that's a good place to wrap up and leave you to explore the math package some more. Next time we'll come together, tie it all together, and actually prepare our package for publication. So hopefully in doing this, I'll show you that your package that you made isn't that different from a package such as math. And that can help see what's under the hood, help you feel more confident about using other packages. Okay. So with that, thank you. Thank you all. I'm going to end the recording. If you're joining us later, thanks again. And I'll stay on the line for a few more minutes to see if there's any more questions.